Hi guys, this is Saurav here and welcome to the Vedantu channel on which we are currently doing electrochemistry. How are you guys? कैसे हैं आप सब? Please tell me, please जितना आप respond करोगे chat box पे उतना अच्छा रहेगा. Hello Ajay, hello Gaurav, hello Mrudul. How are you guys doing? क्या हाल चाल है? Last class में हमने क्या किया था? We had discussed some problems on Nernst equation and I was not very well on that particular day, so इसीलिए थोड़ा slow चल रहा था session. आज की session में हम लोग करेंगे, we will be discussing about concentration cells, and concentration cells is one major aspect. Hello Pratyush, hello Shreya, hello Anit. So in concentration cells is one of the key areas of electrochemistry and we would be discussing this in detail. The reason why concentration cells are important is because इसके ऊपर questions बहुत बार पूछे गए हैं. Also it's very easy to understand. Okay, I'm fine Pratyush, thank you, thanks a lot. And so चलो let's start today's session. Hello Mrudul, hello Ritik. Let's start today's session, and before starting today's session let me give you an idea that the Vedantu scholarship admission test, the VSAT, is going to be held on Thursday 1st of August and Sunday 4th of August. Please do register for the test. The registration is completely free. You can benchmark yourself against like multitude of students. Also you can get to know your ranks. और आपको ये भी हो सकता है कि you can get handsome scholarships and prizes for our paid courses. Also please do like, share and subscribe the channel so that you are always updated with the amazing content. If you haven't checked out, KVPY discussion session was conducted by Pulkit sir yesterday. You should also check out like the detailing of the Chandrayaan mission by our very own KR Abhishek sir, and all the amazing things that are going to come in future. You'll always be updated with that. So please do like, share and subscribe. Okay, so chaliye let's start. Hello Shaunak, let's start today's session, and this is the flowchart of things that we have already covered. We have already covered the problems related to Nernst equation, and a small part of Nernst equation that we are going to deal today is concentration cells. We'll be finishing concentration cells today, and in the next session we'll be talking about electrolytic cells. So remember, this is the flow. After concentration cells will come over here. Okay, chaliye let's start today's session with a problem that I had given in the last class, a homework problem that was given in the last class. Question was this, that there is a cell which was cadmium coupled with cadmium hydroxide, cadmium solid hydroxide, NaOH, and the concentration of NaOH is given as 0.01 molar, H2 is 1 bar. You have to identify the solubility product of cadmium hydroxide. Okay, it is, you have to calculate the solubility product of cadmium hydroxide. Did you guys solve it? चलिए इसको solve करने की कोशिश करते हैं. If you have solved it, please do check your calculation as well. So the cell is this. How would we write the reaction? First and foremost, we need to identify that what is the oxidation half cell and what is the reduction half cell. कैसे हम identify करेंगे? So you can see that cadmium is changing into CD2+. So what is this process? This process is oxidation. Okay, cadmium is changing into CD2+. You are seeing that it is oxidation, and you can see that hydrogen is being created. So hydrogen must be created from H+ ion. So this is reduction. Also we know that whatever is written on the left hand side is oxidation, whatever is written on the right hand side is reduction. So let's try to write the equation. Equation इस तरह से लिखा जाएगा, CD solid which will change to CD2+ aqueous. I can write this. CD will change into CD2+ and it will give out 2 electrons. Also I can write 2 units of H+ will change to form H2. ये हम लिख सकते हैं, ठीक है? So this is H2 gas and this is aqueous. This can be written very easily. Now if I add both of them, I will get CD solid plus 2H plus, this will take up 2 electrons. So if I add both of them, the electrons will get cancelled out. 2H plus aqueous, which will change to form H2 gas, plus CD2 plus aqueous. Okay, I will write the reaction like this. Okay, once I've written the reaction like this, I just need to know that for this reaction, Q, the expression for Q will be hydrogen's gas pressure times CD2 plus upon H plus ion concentration whole square divided by CD solid, but I would not be including CD solid. Okay, NaOH में तो OH minus ions है ना? Yes शिव, OH minus ions हैं और OH minus ions को हम यूज करेंगे. देखो आप कैसे यूज करते हैं उसको. So ये एक काम हमने कर लिया. Once this part of work is done, now I will use the Nernst equation, and first and foremost let's look at what is given. It is given that E cell is 0 volts and E naught of the CD2 plus changing into CD is minus 0.39. Now we know that cadmium is undergoing oxidation, तो ये तो reduction potential दिया गया है. So what I'll do is I will change this, I'll reverse this, I will change it to 0.39. So I can write that E cell is equal to E naught for oxidation plus E naught of reduction minus 0.0591 upon how many electrons are being exchanged. Can you tell me कितने electrons exchange हो रहे हैं? The number of electrons exchanged is 2. Okay, the number of electrons exchanged is 2 log of, I will write Q. Q is H2 CD2 plus upon H plus whole square. Isn't it? Very easily we can write this. Now oxidation potential for hydrogen electrode is oxidation potential for hydrogen electrode or reduction potential for hydrogen electrode is 0. I will write reduction potential as 0 and this will be written as 0.39 and this is 0. It is already given that E cell is 0. This is already done. Now 0.0591 upon 2. What is the pressure of hydrogen given? Hydrogen's pressure is 1 bar. So I will write 1 times. So let's not write 1. It's understood. Can I do something over here to simplify this? What I'm gonna do is use a very elegant method. What I'm gonna do is, since it is being asked to calculate solubility product of cadmium hydroxide, solubility product is the product of concentration of ions. So CD KSP of CDOH whole twice is nothing but the product of concentration of CD2 plus and OH minus square. This is the product. Okay, the product of these two terms is the KSP of CDOH whole twice. Now I can see that the numerator has CD2 plus, denominator has H plus whole square. I multiply this with OH minus square and divide it by OH minus square. न्यूमरेटर एंड डिनोमिनेटर दोनों में OH माइनस स्क्वायर से मल्टीप्लाई एंड डिवाइड कर देते हैं. ठीक है, इससे मुझे मिलेगा क्या? व्हाट विल आई ऑब्टेन ओवर हियर? Okay, what will I obtain over here? Now this expression, the numerator will become KSP, and what is H plus ion concentration times OH minus ion concentration? You know this as ionic product of water. ये आपको पता होगा. KW is known as H plus ion concentration times OH minus ion concentration. This value is 10 raised to minus 14. ये आपने पहले पढ़ा है. ओके, दिस यू मस्ट हैव रेड 10 raised to minus 14. Yes? So I will simplify this equation by bringing 0.39 on this side. This will become minus 0.39, 0 minus 0.0591 upon 2 log of, this numerator will become equal to KSP and denominator will become equal to KW whole square. Okay? KW whole square. Clear? It's a very simple way of like shortening the equation. Okay? So अभी negative negative cancel, ये हो जाएगा 0.78 divided by, I can approximate this to 0.06, which will be equal to log of KSP, and KW whole square will be equal to 10 raised to minus 28. Okay, 10 raised to minus 28. So if this will be 13, and what is the anti-log of 13? 10 raised to 13's log is 13, so anti-log of 13 is nothing but 10 raised to 13 multiplied with 10 raised to minus 28 will give me KSP, which is 10 raised to minus 15, and that is our answer. Okay, that is our answer. Okay, so it looks like a difficult question, however it uses concepts from ionic equilibrium as well as electrochemistry. Looks difficult, but you can see that ever you are being asked questions about solubility product, again try to reduce the Nernst equation so as to get this expression for KSP. Okay? Try to reduce the Nernst equation so as to get the expression for KSP. This is the way we proceed ahead. Clear? Chalo. Cool. Let's move ahead and let's talk about the matter at hand, which is concentration cells. Now before I start with concentration cells, let me talk about something known as liquid junction potential. And liquid junction potential is something that somebody had pointed out in earlier sessions. In the sessions where we had talked about galvanic cells, let's look at this construct. This was the construct of galvanic cell. तो galvanic cell में मैंने यहाँ पे क्या लिया था, zinc, and this was zinc sulfate, and this was copper sulfate, and this was copper. This was the negative electrode and this was positive electrode, isn't it? This was the representation: zinc, zinc sulfate, copper, copper sulfate. I had told you that the electrons will travel in this direction. Electrons are gonna travel from zinc towards copper. However, to complete the circuit, what should happen? What should happen? Sulfate ions will move in this direction to combine with newly formed zinc 2 plus ion. Okay? यहाँ पे zinc 2 plus में convert हो रहा है. So there is an increase in the concentration of zinc 2 plus ion. Okay? There is an increase in the concentration of zinc 2 plus ion. So there is an increase in concentration of zinc 2 plus ion. There is an copper 2 plus ion is settling on the surface of copper. So there is an increase in the concentration of sulfate ion, and sulfate ion moves about this membrane. Sulfate ion moves about this membrane. It is a very clear picture. Our circuit is complete. Electricity will start to flow. But what will happen after some time is that the EMF will slowly decrease. Okay, EMF will slowly decrease, and this is because of one major reason, which is known as liquid junction potential. So what is liquid junction potential? Okay? EMF will slowly decrease because of liquid junction potential. The reason why it will decrease is, let's say this is the membrane. Okay, I'm writing it over here. Let's say this is the membrane. Okay, this is our membrane. About the membrane on the left hand side, I have zinc 2 plus ions, I have an accumulation of positive charge, isn't it? Because here we have zinc 2 plus ions. So on the left hand side we have an increase in the concentration of zinc 2 plus ions. So they are slowly increasing. And on the right hand side I have a accumulation of negative charge. Okay, I have an accumulation of negative charge. So before the movement of sulfate ion starts, this particular thing exists, and let's say the movement of sulfate ion does not take place at the same rate at which zinc 2 plus ion is produced, तो भी यहाँ पे zinc cation का amount increase कर जाएगा और यहाँ पे combined anions present रहेंगे. So either sulfate ion does not move, or it moves at a rate different from the rate at which zinc is produced. What will happen? This will increase and this will increase, and it will create an electrical double layer. Can we say that this is an electrical double layer? Electrical double layer. Okay, because of this, because Shiv, let's stop, we'll get to that later. Because of this, it will generate a potential, and this is known as LJP. Because of this, a potential is generated which is known as the liquid junction potential. When liquid junction potential increases, the cell EMF decreases. So remember, when the liquid junction potential increases, E cell decreases, because the circuit is no longer getting completed. There is an accumulation of charge, and at a certain point the cell, this will reach a state of equilibrium and stop supplying current. Okay, so there is a hindrance to the supply of electricity from the galvanic cell, and it is because of this guy, liquid junction potential. Okay, so let's read about what it is actually. So liquid junction potentials, when two solutions of electrolytes of different concentrations are in contact with each other. Okay, the more concentrated solution will have a tendency to diffuse into a less concentrated one, and this will result in a electrical double layer, and which positive and negative charges are at the junction of the two solutions. Because of this, the liquid junction potential interferes the exact measurement of the EMF of the cell, and so its effect should be minimized. I need to minimize the effect of liquid junction potential. Okay, I need to minimize the effect of liquid junction potential. I hope this is clear. Let's move on to what comes next. How do we minimize this? इसको minimize करने के दो तरीके हैं. एक तरीका हमको मालूम है, by using salt bridge. I separate the solutions. Okay, I separate the solutions. These two solutions, when they were in contact with each other, resulted in a difference in the rate of movement of sulfate ion, and जिंक के साइड मूव करेगा. सर पर आपने बोला कि सल्फेट, या बेटा सल्फेट आयन जिंक की तरफ मूव करेगा, लेकिन जिंक जिस रेट से पानी में प्रोड्यूस हो रहा है और सल्फेट जिस रेट से जा रहा है, अगर वो रेट्स में थोड़ा भी डिफरेंस आया तो क्या होगा कि जहाँ पे जिंक प्रोड्यूस हो रहा है वहाँ पे जिंक का अमाउंट इंक्रीज कर जाएगा, एंड जहाँ पे सल्फेट प्रेजेंट है वहाँ पे सल्फेट का अमाउंट इंक्रीज कर जाएगा. अनकम्बाइंड सल्फेट ज़्यादा हो जाएगा, अनकम्बाइंड जिंक भी इंक्रीज कर जाएंगे, एंड बिकॉज ऑफ दिस जहाँ पे उन दोनों लिक्विड्स का जंक्शन है, दिस जंक्शन विल क्रिएट अ इलेक्ट्रिकल डबल लेयर. ओके, एंड अगर डबल लेयर क्रिएट हो गया तो पोटेंशियल भी आएगा, एंड इफ पोटेंशियल कम्स द सेल ईएमएफ विल डिक्रीज. नाउ हाउ डू वी एलिमिनेट दिस? वी एलिमिनेट दिस बाय यूजिंग अ सॉल्ट ब्रिज. व्हाट इज अ सॉल्ट ब्रिज? वी नो what a salt bridge is. What we do is we take copper sulfate, copper, zinc, zinc sulfate, and in this inverted U-tube, I take KCl or KNO3, NH4Cl भी हम ले सकते हैं. All of these ions are taken, all of these salts are taken over here. Now, what is the ion which is increasing in this solution? Zinc 2 plus is increasing. Okay, NaNO3 भी ले सकते हैं. Zinc 2 plus is increasing. Zinc 2 plus को neutralize करने के लिए हमें क्या चाहिए? कुछ anions चाहिए. Then anions will come from here. These anions will be either chloride or nitrate. Cool. So chloride or nitrate ions will come in this direction. Over here, sulfate ion is increasing, and to reduce its concentration or to combine it, K plus ion will come over here. So you can see that the movement of ion is ensured without allowing the liquids to come in contact with each other. Okay, हम इन दोनों liquids को contact में आने नहीं दे रहे हैं, but we are still ensuring that the sulfate ion and the zinc 2 plus ions are combined. Shiv, I'll get to you about that later. Sulfate की मात्रा ज़्यादा हो जाएगा और कल निकलने नहीं देगा. Similarly, vice versa. Obviously, Shiv, an equilibrium will come and this will stop the movement. And because of that, we need to eliminate liquid junction potential by using a salt bridge. एक method होता है salt bridge. Okay. This is already known to you guys, so I will not spend a lot of time on it. Just remember that we use an ion over it. यहाँ पे हम potassium chloride or potassium nitrate or sodium nitrate, why do we use this? Why do we use KCl or KNO3 or NaNO3? The reason why we use these salts is that the mobility of cation should be equal to anion. These are those salts in which the mobility of the cation is equal to that of anion. Okay? Not only the maintenance of neutrality, these are those salts in which the mobility of ions is equal. We just cannot take sodium chloride. Salt bridge है तो sodium chloride नहीं ले सकते हैं. We have to take those salts in which the mobility of cation is the same as mobility of anion, so that equal number of the neutralization of sulfate takes place at the same rate at which the neutralization of zinc 2 plus is taking place. Okay? So with this thing in mind, let's move on to the next method of eliminating liquid junction potential. And then salt bridge, आपको मालूम है, salt bridge in electrochemistry is a laboratory device used to connect the oxidation reduction half cell, maintains electrical neutrality, preventing the cell for rapidly running into equilibrium. And if no salt bridge is present, the solution of one half cell will accumulate negative charge and the other one will accumulate positive charge, preventing further reaction. So salt bridge is essential, otherwise cell reaction नहीं हो पाएगा. What is then another way of avoiding liquid junction potential and ensuring कि cell काम करता रहे? That is known as concentration cell. Another way of avoiding liquid junction potential is concentration cell. Let's look at what concentration cell is. A concentration cell, आप देख रहे हैं concentration लिखा हुआ है. You can see that the term word concentration is written. So it is a cell whose basis lies on concentration of things which are involved in galvanic cell. Concentration is same, आता हूँ मैं उस पे. So in a battery technology, a concentration cell is a form of a galvanic cell that has two equivalent half cells which only differ in concentration. उनमें difference सिर्फ concentration का रहता है, क्योंकि we know that change in concentration can also change the EMF. So if I change the concentration keeping the composition same, the cell will still work. Okay. So it's a form of a galvanic cell in which two equivalent half cells are present. They are differing only in concentration. Clear? Now, let's look at the types of concentration cells. There are two types of concentration cells. One is known as the electrode concentration cell, one is known as the electrolyte concentration cell. Let's look at what is an electrode concentration cell and what is an electrolyte concentration cell. Assume that you can see that the whole vessel contains one liquid. एक ही liquid present है. Okay, एक ही liquid present है. Do not mix का है ही नहीं. उसमें सिर्फ एक ही liquid लेते हैं. ठीक है? We have taken only one liquid. Let's say we have taken only HCl. Okay, I have taken only HCl, and on this side of the this cell, I have covered the electrode with a glass or glass shaped cover through which hydrogen can come in. Hydrogen gas can come in. Okay? Let's say this electrode is made up of platinum. This electrode is made up of platinum. You can see the construction. I have taken HCl. The electrode is of platinum. I have covered it with glass in which hydrogen can be pumped in. On the other side as well, the same thing happens. So hydrogen can come in from here. ठीक है? यहाँ पे हाइड्रोजन गैस रहता है. This is also platinum electrode. ठीक है? So this is the construction. Why it is known as electrode concentration cell. देखो एक बात समझने की कोशिश करो. You can see that the platinum electrode is not the electrode we are talking about. Platinum is only providing the surface where reaction will take place. Okay? Platinum is only providing the surface on which hydrogen would be adsorbed and reaction will take place. What is common? What is common for both these electrodes? Common entity is HCl. Common entity is HCl. Assume that its concentration is C1. Okay, assume that its concentration is C1. Can I say that in the oxidation half cell, this reaction will occur? In the oxidation half cell, this reaction will occur. Hydrogen will get converted to H plus and will give out an electron. This is hydrogen gas. Okay? In the oxidation half cell, this reaction will take place. Hydrogen gas, it is nothing but a hydrogen electrode kind of a setup. So hydrogen gas will change into H plus in the oxidation half cell. In the reduction half cell क्या होना चाहिए? Reduction half cell में क्या होगा? H plus will take up an electron and will change into half H2 gas. बोलेंगे? ठीक है? लेकिन कुछ एक चीज डिफरेंट है and something is common. You can see that this H plus is coming from HCl. This H plus is coming from HCl. So H plus is common for both of them. The H plus ion which is available for this and H plus ion which is available for this is exactly the same. However, this hydrogen which is pumped in is at a pressure P1 and this hydrogen which is pumped in is at a pressure P2. ये दोनों हाइड्रोजन का प्रेशर डिफरेंट है, बट ये HCl जो है उसका दैट कंसंट्रेशन इज इक्वल. सो कैन वी से दिस दैट E for oxidation half cell will be equal to E naught for oxidation half cell, okay, minus 0.0591 by 1 log of H plus ion concentration by hydrogen pressure of hydrogen to the power 1 by 2. Can I say this? Can I say this? Oxidation half cell, this is the oxidation half cell for which I write E naught OHC minus 0. Number of electrons exchanged is 1 and log of H plus whatever is on the product. इसके लिए Q क्या लिखा जाएगा? Product by reactant. So product is H plus and reactant is hydrogen which is in gaseous form. So pressure of hydrogen to the power 1 by 2 because the prefix is 1 by 2. Can I do this? Okay, इसको लिख लेंगे. I can also write it for reduction half cell. So E for reduction half cell will be written as E naught for reduction half cell minus 0.0591 upon 1 log of pressure of hydrogen to the power 1 by 2 upon H plus ion concentration. Now these pressures are different. These pressures are different and let me write this over here. If I add the E cell and if I add E for oxidation half cell and E for reduction half cell, I'll get E cell. तो E cell में क्या लिखूंगा? E cell will be E naught for oxidation, E naught for oxidation half cell and E naught for reduction half cell. Can you tell me if this sum will be equal to 0 or not? Because we are taking the same reaction in forward and backward direction. Hydrogen changing into H plus changing into hydrogen. So the sum of these two will be equal to 0. Sum of these two will be equal to 0. Okay. I can take 0.0591 by 1 common. ये common ले लेते हैं. Log of H plus ion concentration, I will write H plus by pressure of hydrogen in the oxidation half cell to the power 1 by 2 times pressure of hydrogen in the reduction half cell to the power 1 by 2 upon H plus ion concentration. Okay. Now since HCl is common for both of them, I will cancel out both of them. H plus को cancel कर दिया हमने. Our E cell becomes 1 by 2 को I take 1 by 2 common and I will write this as minus 0.0591 upon 2 log of pressure of hydrogen in the oxidation half cell upon pressure of hydrogen in the reduction half cell. This becomes my EMF. Okay, this becomes my expression for cell EMF. Now tell me something. If I want to make this cell work spontaneously, what should be my expression for delta G? If I want my cell to work spontaneously, what should be delta G? Delta G भाई साहब होने चाहिए क्या? Negative. Delta G should be negative. Okay? Shreya will get to that. अब देखो ना, delta G negative लिखेंगे. अगर delta G negative लिखा है तो E cell क्या होना चाहिए? E cell should be positive. But are we getting a positive result? No. Our expression has negative. इसको positive में कैसे convert करना है? How do we convert this into positive? By taking pressure of hydrogen in oxidation half cell less than pressure of hydrogen in reduction half cell. Okay? Yes, Kavita, it is applicable only at 298. हम लोग 298 पे ही measurements कर रहे हैं. So if I take this condition, Won't you think अगर ये हम छोटा ले लेते हैं ये बड़ा ले लेते हैं, then this will become positive and so our E cell will become positive. So remember, whenever you are given this setup, then the cell, the region or the glass or the hydrogen electrode where pressure is less, that should be oxidation half cell, and where pressure is more should be reduction half cell. Is that clear? This is, you can deduce it on your own. मैंने डिडक्शन करके आपको दिखा दिया है कि ये प्रेशर यहाँ पे कम होगा तभी सेल स्पॉन्टेनियसली वर्क करेगा. Clear? So are you able to understand? Clear? Let's move on to the next concept. Okay, let's move on to the next concept. So this was electrode concentration cell. अगर हमने electrode when are we gonna learn this? When are we gonna learn fuel cells? उसको हम एकदम एंड में लेंगे. ओके, एकदम डिफरेंट टॉपिक है वो थियोरेटिकल है काफ़ी, तो उसको एकदम एंड में लेते हैं. There is a small mistake over here. This has to be electrolyte. This has to be electrolyte. If I keep the electrodes alike but change the electrolyte, I'm changing the electrolyte, you see that the color of electrolyte is not changed. मतलब electrolyte का nature change नहीं कर रहे हैं, I'm only changing its concentration. So let's say there is electrode like zinc, और ये zinc sulfate है, और ये भी zinc है, और ये भी zinc sulfate है. Looks a little awkward because we are generally programmed to see copper over here and copper sulfate, but ये एक concentration cell जैसा behave करेगा. यहाँ पे absolutely no issues will happen because zinc sulfate concentration over here is just C1 and zinc sulfate concentration over here is C2. Rest nothing is gonna change. Okay, nothing is gonna change. This zinc and this zinc is alike, their activities are alike. So if I want to write oxidation reaction, I will write this as, I'm sorry guys, zinc changing into zinc 2 plus gives out 2 electrons, and reduction will be written as zinc 2 plus taking up 2 electrons changing into zinc. Okay, clear? I will write it like this. If I write E for oxidation half cell, I will write it as E naught for oxidation half cell minus 0.0591 upon how many electrons? 2 log of zinc 2 plus ion concentration in oxidation half cell by zinc. ठीक है? Zinc 2 plus ion in oxidation half cell by zinc. And for reduction I will write it as ERHC is equal to E naught for RHC minus 0.0591 upon 2 log of zinc by zinc 2 plus in the reduction half cell. Okay, if I add both of them, what will be the sum of E naught oxidation and E naught reduction? If I add both of them, I will get E cell. What will be the sum of E naught oxidation and E naught? See, Shiv, zinc is not gas, so it will not be taken as pressure. Okay, zinc is not a gas, so it will not be taken as pressure. मतलब आप उसको pressure वाला term use नहीं कर सकते हो. So E naught oxidation plus E naught reduction will be equal to 0 because the same reaction is happening. So इसको हम 0 ले लेते हैं and minus 0.0591 upon 2 log of, I can write zinc 2 plus of oxidation half cell upon zinc 2 plus of reduction half cell. Can I do this? Okay, I can do this. So I am getting an expression to calculate EMF even by keeping the electrode constant and changing the concentration of electrolyte. Now इसका concentration zinc 2 plus, इसका concentration क्या है? C1, इसका concentration है C2. Now what should be the relation between C1 and C2? What should be the relation between C1 and C2 so that this cell works spontaneously? For it to work spontaneously, delta G should be negative, and so difference between electrolytic and electrochemical cell. Anamika, electrochemical cell is where we generate electricity from chemical reaction, और electrolytic में वो होता है जहाँ पर कि हम electricity supply करके chemical reaction करते हैं. Okay? So to make this work spontaneously, I need this to be positive. So oxidation half cell में concentration कम रहना चाहिए. So this concentration should be less than this concentration. 2 is cancelled on adding. Yes, it is cancelled on adding, but that does not mean that this 2 represents number of electrons exchanged in this equation. Okay, so now you see that I have not encountered liquid junction potential and still I am getting EMF by just changing the concentration. Clear? I'm just changing the concentration and getting this result. So with this idea, let's do some problems. Okay, I hope this is understood. Let's do some problems. So let's take this question. So the first question is this problem 2, because problem 1 was the homework question. So CO, that is cobalt changes to CO2 plus, whose concentration is C2. Just look over here. Please keep in mind that this is C2. CO2 plus C1 changes to CO. Okay? जो लेफ्ट में दिखाया गया है वो क्या होता है? ऑक्सीडेशन हाफ सेल. The one which is shown on the right is reduction half cell. For this cell, delta G is negative if. For this cell, delta G is negative if. Think carefully. Delta G is to be made negative. Delta G negative means cell is working fine. Cell is working spontaneously. E cell should be positive. What should be the answer? Ajay Singh has given an answer. Ajay Singh is saying B. Anit says A. Shiv says A. What about other people? Shreya says B. Anamika B. Okay. So this, what kind of, can you please tell me what kind of, Kavita says A, Ashwin says A. Can you tell me what kind of a electrochemical cell is this? What kind of a concentration cell is this? Our electrodes are constant or electrodes are alike. What is different? Electrolyte. So this is what kind of a cell? This is an electrolyte concentration cell. This is an electrolyte concentration cell. So if this is an electrolyte concentration cell, and if I look at the reaction, I will write E cell as equal to minus 0.0591 upon 2 log of CO2 plus in oxidation half cell CO2 plus in reduction half cell. How would I get E cell to be positive if CO2 plus in oxidation half cell is less than CO2 plus in reduction half cell? In this scenario, E cell will be positive or delta G will be negative. Clear? So CO2 plus in oxidation half cell is given as C2 and this is given as C1. So C2 should be less than C1. Answer should be B. Okay? The right answer should be B. It's a very simple question. Next, Next question is this. Okay, it's a very simple question. Next question is this. In a concentration cell, same reagents are present in both anode and cathode compartments, but at different concentration. Calculate the EMF of a cell containing 0.04 molar Cr3 plus in one compartment and 1 molar Cr3 plus in the other if Cr electrode is used in both. If Cr electrode is used in both. Okay, first and foremost you have to figure out ki what kind of a concentration cell are we talking about if we are changing the concentration of these ions in both compartments. कौन सा concentration cell के बारे में बात कर रहे हैं? Which concentration cell are we talking about? It's a electrolyte concentration cell. Very good, Ajay. Very, very good. We're talking about an electrolyte concentration cell. So, correct. So, please try to identify what is the answer to this question. So, when we are taking an electrolyte concentration cell, our equation should be E cell should be equal to minus 0.0591 by N log of ion concentration in oxidation half cell by ion concentration in reduction half cell, isn't it? Ion concentration in oxidation half cell and ion concentration in reduction half cell. Now what ion concentration in oxidation half cell should be less as compared to ion concentration in reduction half cell so that E cell will be positive. तो ये हम minus 0.0591. एक बात बताइए, what is the number of electrons? Cr3 plus है, तो ये कहाँ से किस में convert हो रहा होगा? Maybe Cr electrode. So it's given Cr electrode. So the number of electrons is 3 electrons. Okay, number of electrons is 3. Log, what should I take as the numerator? I should take the smaller value as numerator. Numerator will be 0.04 and denominator should be the larger value 1. So this is present in the oxidation half cell. This is present in the reduction half cell. Okay. So what should be my answer? बताइए कितना आंसर होना चाहिए? What should be my answer? So you can see this working right now. What should be the answer? From here it should not be difficult. So this will turn out to be 0.02 and log of 0.04 will be, log 4 कितना होता है? 0.6020. Okay, and 4 by 0.083. Are you getting 0.083? Log 4 is equal to 0.6020. So, and this will turn out to be 2. It's C. Okay, chaliye, if you're getting the answer as C. इतना टाइम नहीं होता पेपर में. यार पेपर में टाइम नहीं होता है तो निकालना पड़ेगा आपको. क्वेश्चन जल्दी सॉल्व करने होंगे. ओके, सो this gives us the answer, and I don't think this concept is, I guess, clear to you guys, that how does concentration cell work. Okay, it's a very specific part of Nernst equation where we are supposed to utilize a small fragment of Nernst equation to arrive at the solution. Now I'm giving you a question, and the question is this. Okay, the question is this. This question is slightly difficult. Okay, this question is slightly difficult because this question is of advanced level. The question is that the cell diagram shows 1 liter of buffer solution of HA. I'm just gonna write this. This solution contains HA and NaA. Okay, concentration is 0.1 molar and concentration is 1 molar. Hydrogen gas is at 1 bar. Hydrogen gas is at 1 bar. Hydrogen gas is at 1 bar. Over here, HA is 1 molar. NaA is 1 molar. You are given that the pKa value for HA is is 4. You have to calculate the EMF of this cell. Okay, it's not a electrode concentration cell, it's a electrolyte concentration cell, because I'm changing the nature of electrolyte. Electrode remains the same. Hydrogen electrode 1 bar, it remains the same. But electrolyte is changing. So this is an advanced level question. Try to solve this. Try to post your answers in the comment section. And we will discuss this question in the next class, the starting of the next class. The next class would be on the electrolyte. The next class will be on the electrolytic cells, electrolytic reactions, and please do join us on that particular day, because that's the second part of electrochemistry which we need to master, because usse bhi questions aate hain. Faraday's laws, electrochemical series, electrolytic cells, electrolytic reactions, what gets discharged, what doesn't get discharged. So please do join us on that very day. And with that, I take leave for today. Please do remember that Vedantu is starting with 1 year long-term program, and through VSAT you can avail handsome scholarships to this program. It has a lot of amazing features, and please do remember that appear for VSAT on Thursday 1st of August and Sunday 4th of August, irrespective of the fact that you want to take the course or not. Okay, chalo, this is Saurav Goswami taking leave, and I hope you had a lovely session today. Please do join us in the next session, because we'll be discussing electrolytic cells. Chaliye, bye bye guys, and have a lovely time.